For my project, I decided to look into the concept of meta-learning. So what exactly is meta-learning? Basically, the concept is learning to learn. It's similar to what we do as humans. As children, when we grow up, we learn how to ride bikes, we learn our colors, our numbers, our shapes. We're constantly learning as we get older, and we apply things that we've learned in the past to things that we can learn in the future. So with meta-learning, what we're doing is we are exposing a model to a variety of tasks and then testing it and how well it can learn new ones based on what it learned previously. The new tasks, however, are ones that it has not seen before. So it's taking that previous knowledge and applying it. One of the benefits is that this can be accomplished using only a few training examples if there's not that many available. This can be applied to reinforcement learning, supervised learning. There's not really a set specific algorithm for meta-learning. What I've seen is that it's more of a concept. There are three common approaches to meta-learning. The first is metric-based, which is a similar concept to nearest neighbors. Model-based, in which there is an external or internal memory and the parameters are updated based on the internal or external memory. And then optimization-based. This is what I have found to be the most common one, the most basic to understand. Basically, you've got optimized parameters that are specifically set for fast learning, and this is what is ideal to use when you only have a few examples. One of the more straightforward methods of optimization-based meta-learning is few-shot classification. Your data set is broken into two parts, your support set for training and the prediction set for testing. Now, this is set up as a K-shot N-class method, where K is the number of learning opportunities or shots in each support set, and N is the number of classes that need to be classified. When we're testing and when we're training, we want to make sure that we are testing the same way that we're training in order to reduce error. We have two parts, the meta-learner and the fast learner. The meta-learner is the first trainer. It is exposed to a large number of tasks or data sets and learns how to accomplish each one of these tasks. It then trains or teaches the fast learner how to accomplish each task. The fast learner is then exposed to a new unseen task and takes what it learned previously to figure out how to accomplish that task. So here we have a training set and a testing set. As you'll notice, each part of the data set has got 4 images and 2 classes. If we think back to K and N, this is considered a 4-shot, 2-class image classification. Now, as you'll also notice between the training and testing, they have nothing in common, and that is part of the point of meta-learning. You're training on specific tasks, and we're in this case images, and then you're testing its ability on completely unseen data. In this case, the dogs and the otters, which it has never seen before. And so we're hoping that it's learned enough that it can apply what it's done previously to what it's seeing now. So what exactly can we do with meta-learning? One of the more obvious applications would be artificial intelligence. One company called OpenAI essentially trained a robotic hand how to solve a Rubik's Cube. They put it under different circumstances by putting a glove on the hand, by poking it, distracting it, and each time it's learning from its environment and applying that to the future in order to solve that cube. Another company called Uber AI Labs created their own algorithm called the POET algorithm. Now what this does is it takes a bipedal walking agent that is walking along a path. It might be flat, it might be hills, but what makes this algorithm interesting is it's not being fed outside data from us that it's learning on. It's actually changing itself and learning from itself. Another application could be for rare disease classification. Obviously, there's only so many cases of certain diseases around the world, so this would be an interesting application.